So hopefully you watched the two Moving Man videos before watching this and got an idea of how the distance time graphs look as the person moves. So just a reminder that in a distance time graph, it is a line graph, and on the x-axis it shows the time, and on the y-axis it shows the difference. Lines always move from left to right, never from right to left, because time is always going forwards. But distance, the lines could be going up or down depending on which direction the person is moving. The other thing you need to keep in mind is that the origin here at 0, 0 represents what we call the target, and what the target is depends on the situation. So that could be his home, his school, or whatever. So it says here, Billy Bob is going for a walk. His home is the origin. So right there at 0, 0, and in this case, it's referring to this graph, 0, 0 is representing his home. So if the graph starts here, that means he is starting at home. If the graph were to start up here, it means he is not at home. So 0, 0 is representing his home. In this case, the graph is starting there, so he's starting at his home. So the first question is, what is he doing in part A? Part A is a straight line and it's sloping up. So it's starting at 0 and it's sloping up and it's a straight line. So for part A, a straight line means the person is moving at a constant or steady pace. And if the line is moving up, it means that he is moving away from the target. So in section A, he is walking away from the target, which is his home, from home at a constant speed. Now the other thing is you are going to need to say what the speed is. And the speed is just the application of rate of change in these types of questions. So the rate of change is how much his distance is changing divided by how much his time is changing. So to calculate the speed, you're going to treat it like a rate of change question. So if you remember, when you have a graph, what you do is you make a right angle triangle, and the rate of change is equal to the same as the speed, and it's the rise over the run. Now the rise, you can see the distance is going from 0 up to 10. So the rise is 10 meters. And the run is going from 0 seconds to 5 seconds. So that's 5 seconds. And 10 divided by 5 makes 2 meters per second. So his speed is 2 meters per second. In question B, it says, what is he doing differently in section B? So in A, he was moving away from home because it's a straight line and it's moving up. In B, the line is moving down. So when a line moves down, moving towards the target. It's still a straight line, so he's still moving at a constant pace, but this time he is walking towards home at a constant speed of, and now let's calculate the speed. So we're starting here and ending here. We're going to make our rate triangle. So the rate of change is the speed, and it's the rise over the run. Now, if you take a look at the rise, it's going from 10 meters down to 2 meters. So normally we would say that the rise is -8, but with speed, that is an application of rate of change that we don't consider to be negative with these distance time graphs. So the fact that it's decreasing is more just a symbol that he is walking towards the target, not that the speed is negative. So we're going to keep the rise positive. It's going to be 8, and the run is going from 5 seconds up to 8 seconds. So the run is 3 seconds. And when you divide these, you get an approximate value of 2.7 meters per second. So he's walking towards home at a constant speed of approximately 2.7 meters per second. Now the next question is he traveling faster in A or D? Now, you could calculate the speed of D using this method, but what you can also do is just take a look at how steep line A is and how steep line B is. And in the Moving Man, we talked about it, and you can see it over here, that if the line is steeper than this line, what that means is he's walking at a faster pace. And it doesn't matter if the line is increasing or decreasing. If it's steeper, he is walking at a faster pace. So he is traveling faster in D because the line is steeper. So you could answer it that way, or you could calculate the actual speed of D and show it that way. The next question is, what is he doing in section C? I'm just going to circle this. So that was D, that was B. So now section C. So in section C, it's a horizontal line. And you could take a look here, horizontal line. So number 3 says if it's a horizontal line, it means the person is not moving, they are standing still. So horizontal line means that they are staying still. So in D, he is standing still. For, if you look at the time, it's from 8 seconds up to 13 seconds. So that's for 5 seconds. And lastly, what is he doing in section E? Now, E is a curve, so that means he is not walking at a steady pace. He is either accelerating or decelerating. Now, to find out if he's accelerating or decelerating, you have to see if the steepness is increasing or decreasing. So if you take a look at this, we start off with a steep curve, and then as it curves, it becomes less steep. So the steeper it is, the faster he's going. So that means he's starting off fast, and then as it becomes less steep, he is becoming less fast, which means he is slowing down. So that is decelerating. So he's decreasing his speed. And because the line is going down, it means he is moving towards his home. So he is decelerating towards his home. And because it is not a constant speed, you're not able to calculate the speed of it. So you would not calculate the speed because decelerating means the speed is changing. So if you want to see how this all works again in a simulation, you can go back and watch the Moving Man videos. But other than that, what I would suggest is that you take a look at all of these. So lines that are moving up, any kind of line that is moving up, whether it's curved or not, means he's moving away from the target. Any lines that are moving down means he's traveling towards the target. Any lines that are horizontal means he's standing still. Steeper lines means he's traveling faster than this. And if it's curved, it means he is traveling at a changing speed. If it's straight, he's traveling at a constant speed. And to find out if he's accelerating or decelerating, you have to see how the steepness changes. This line number 5, it starts steep and then becomes less steep, so that means he's slowing down, he's decelerating. This blue line number 6, it starts off less steep and then it becomes more steep, so he's picking up speed, so he's accelerating.